This lesson describes three operations you can perform upon two matrices. The first one we're going to look at is addition and therefore subtraction. It turns out that you can sometimes add or subtract two matrices. The second one we're going to look at is called scalar multiplication. And the third one that's going to be briefly introduced in this video is matrix multiplication. Sometimes you can multiply two matrices together. Remember to take notes as you watch this video. If you sometimes need to pause the video to take good notes, then go ahead and do that. So first, for addition and subtraction, when can you do this? Well, it works if and only if the two matrices are the same dimensions or the same size. So anytime two matrices are the same size, you can add or subtract them. And then, of course, you need to know how you're going to do that. Well, in the most obvious way possible, just entry by entry. So on the next screen, we'll look at an example. Alright, so first of all, notice that these two matrices are exactly the same size. And when we add them together, we're going to get another matrix that's also that same size. So I know there's going to be two rows. And to get the first entry, I'm just going to take the 3 and add it to the 8. That gives me 11. Moving over, it's negative 2 plus 3, that's 1. And then 6 plus 0 is 6. And then 0 plus 7 is 7. Then I'm going to do the same thing with the second row. I'm going to add this 1 to this negative 5, and that gives me negative 4. Then I'm going to add this W to this 3W, that will give me 4W. And then 3 plus negative 3 is 0. And in the last one, negative 1 plus M, well, I'm just going to write M minus 1. And there you have it. That's the sum. Turns out, in a very similar manner, you can subtract two matrices. So here you have the very same matrices, but now I'm going to subtract the second one from the first. So this time it's not 3 plus 8, it's 3 minus 8, that's negative 5. And then negative 2 minus 3, negative 5. 6 minus 0, and 0 minus 7. And then for the second row, it's 1 minus negative 5, or 1 plus 5. And then W minus 3W, negative 2W. 3 minus negative 3, 6. And negative 1 minus M. I'll just write negative 1 minus M. And that's how you add or subtract two matrices. In this example, it's sort of a trick question. You cannot add these two matrices together because their dimensions are not the same. So, cannot do this one. And you should be aware that sometimes that's what happens. You have two matrices, you can't add them together because they're not the same size. Alright, the next operation you're going to learn about is called scalar multiplication. And scalar multiplication works if and only if, well, basically anytime you have a number, which we're going to call a scalar, and it's being multiplied by a matrix, you can always do that. It's always something you can do. And how do you do it? Well, I'm going to suggest you think of it as being just like the distributive property. I'll show you what I mean on the next screen. If you're asked to multiply this matrix by 3, you're just going to multiply each and every entry by 3. So you're going to do 3 times 2 is 6, 3 times negative 8 is negative 24, and 3 times 0 is 0. So it's as if you're distributing the 3, or the scalar, over the entire matrix, and it scales the matrix up in this case, which is why it's sometimes called a scalar. Alright, in this next problem, you'll notice we're putting a couple of skills together. So I'm going to do this one in steps. First, I'm going to go ahead and multiply the -2, the scalar, by each entry in the matrix, giving me -6, -2, 0, and +10. And then I'm going to triple everything in the second matrix. 3 times -8 and 3 times 2. And then to finish it off, I now need to subtract. So -6 minus 3 is -9. -2 minus 24 is -26. 0 minus -24. 0 plus 24, and then 10 minus 6. And there you have it. Alright, the last of the operations is matrix multiplication, and this is multiplying two matrices together. This one works under very special conditions. It turns out that the number of columns in the first matrix has to be equal to the number of rows in the second matrix. And as far as how you go about doing this multiplication, this is something that I would rather explain in person than in a video, so you'll see that next time in class. For now, just get this into your notes. For your homework, copy down the problem below and then work it out. Have that ready for class next time.